Good afternoon. This is for Algebra 1B. I wanted to get you some project help on project number 1. So here's some examples and some help. So we're going to start with lesson 2. And the first problem is Mary is building a fence for her horses. The red square represents the barn and the green space is the field she will be building around. The perimeter of her fence is 2,400 feet. Find the value for x. Note that my numbers are a little bit different than what's shown in problem 1 of your project. Please note that this is just an example. So what we want to do is build a fence around the field to keep the animals in. So please note that the perimeter is going around the field. Okay, just where those dotted lines are showing. The barn is fencing that other side, so we don't want to count that. But note that we don't know the length of one side of our field. However, we know it because we know it's a rectangle. So we can go ahead and fill that in, and that's 7x minus 530. Then we need to add all those up to see how much fencing material we need. So once again, we're adding it all up. Click, 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 okay, to get all the sides of our fence. So I'm going to go ahead and just add each of those up. When we add all our lengths, we know we get a perimeter of 2,400. So then I'm going to go ahead and take my like terms. Note that like terms are ones that have the x's next to each other because that's a variable with the same exponent. So we've got our 7x, our 11x, and our 7x. So note that I just rearranged my equation to show the ones with x's in front. And we can do that by the commutative property of addition and subtraction. The commutative property of addition, not necessarily subtraction. But when I did the subtraction, I added a negative number instead. So basically it all falls under the commutative property of addition. So we have 7x plus 11x plus 7x, and then we're going to add negative 530 plus 260 minus 530. And when we do that, we get 25x minus 800 is equal to 2,040. Then from here, we want to go ahead and solve for x on that left-hand side. So in order to do that, we first have to get rid of the 800, and the opposite of subtracting 800 is going to be adding 800. And what we do to one side, we also have to do to the other. So we're going to add 800 to both sides, and when we do that, we get 25x is equal to 3,200. Then we want to get x by itself, so we've got to move that 25. The 25 is multiplying by the x, so the opposite of multiplication is division. So we're going to go ahead and divide both sides by 25. And when we do that, we get x is equal to 128. Okay, we're going to go on to problem 2. So Trey wants to measure the width of the river. He marks off 2 right triangles as shown in the figure. The base of the larger triangle has a length of 62 meters, and the base of the smaller triangle has a length of 29 meters. The height of the smaller triangle is 22 and 4/10 meters. How wide is the river? Round your answer to the nearest meter. So we're going to go ahead and use a proportion. So we're going to first look at the larger triangle, and I just chose that one because it was listed first in the problem. And our larger triangle, we have 62 meters is our length right there, and then our height, we don't know. That's what we're trying to find, how wide that river is. So I'm going to go ahead and put an x. Note that those two are related because they're on the same triangle. Then on the other one, we're going to go ahead and put 29, which is the other length, or the length of our smaller triangle, and then the height of our smaller triangle is going to go on bottom because we want both our heights to be on bottom, which is 22 and 4/10. Note that the two on the right are related because they're both on the smaller triangle. So ones on the left are part of the bigger triangle, ones on the right are part of the smaller triangle. Then we've got lengths on top and heights on bottom. So therefore we've got a circle of relationships and know our proportion is correct. Then we can continue to use cross multiply to solve. So we're going to go ahead and do our cross multiplication, and we get 29 times x, and then remember the equal sign is double shaded, so we're going to set them equal to 62 times 24, or 22 and 4/10. Then when we do that multiplication out on the right, we get 1,388 and 8/10 is equal to 29x. Then we want to go ahead and get x by itself. So we go ahead and divide both sides by 29. And when we do that, we get x is equal to 47 and 88/100. But then note that we want to round to the nearest meter. So because the 8 is bigger than 5, we go ahead and round up that 7. So add one more to the 7 and that's where we get the 48 meters. Okay, then question 3. We get Amanda made $150 for 10 hours of work. At the same rate, how many hours would she have to work to make $345? So once again, this is one that's easily solved with a proportion. We have 150 for 10 hours, and I put dollars over hours, and those are related because that's what it told us, 150 for 10 hours. And then on top, I've also got to put dollars, which is 345, divided by the hours. And in this case, we don't know what our hours is, so we're going to put an x. Then we're going to go ahead and cross multiply. So 150x is equal to 345 times 10. 345 times 10 is 3,450. And then we want to get rid of the 150 next to the x, and it's multiplying by the x, so the opposite of multiplication is division. So we're going to go ahead and divide both sides by 150, and we get x is equal to 23 hours. So she would have to work 23 hours to make $345. Okay, let's go ahead and move on to lesson 3. So this one was a really tricky one. So let's go over an example problem. A certain road can be represented by y equals 2x minus 8. A new shopping center has opened up and can be represented by the coordinates 3, 5. The city plans to build a perpendicular entrance from the shopping center to the main road. Find the equation that represents this line, shown in green. So I went ahead and drew a diagram here. Note that mine is a little different. The first thing we want to do is find the slope of our equation. So note that top equation there, y equals 2x minus 8. Remember the form y equals mx plus b, where m is our slope. So note that that 2 is in our m's place, or is our slope. So I went ahead and wrote a 2 down there. And then to find a line that's perpendicular, we want to take the opposite reciprocal. So the opposite of 2 would be, well, let's go ahead and write, sorry, I'm getting ahead of myself, 2 over 1, because remember, anything divided by 1 is just, so we can go ahead and write that over 1. And when we're writing slopes and trying to find the opposite reciprocal, it's best to write it in fraction form. So once again, we can just turn that into a fraction by putting it over 1, because 2 divided by 1 is just 2. Okay, so the opposite of 2 is negative 2. So the opposite of positive 2 is negative 2. If we had a negative number, the opposite of negative would be positive. Then the reciprocal means that we're going to flip the two numbers. So the 1 is going to go on top and the 2 goes to the bottom. And that's why it's helpful to have that fraction. So once again, the opposite of positive 2 is negative 2. And then the reciprocal, the numerator and the denominator switch. Okay, so that's going to be the slope of our new line. The other way you could do that is by counting the squares. We went down 1 and over 2 to get to the next point. Over to the right 2. Or if you're looking at it the other way, we went to the left 2 and up 1. If you didn't follow how I was doing that on the graph, just worry about finding the slope from the equation and doing the opposite reciprocal for now. So then we're going to use our equation y equals mx plus b. Remember how I said m represents the slope, so we're going to go ahead and put our slope right there. So we've got y equals mx plus b, and now we have our coordinates listed. So that's our 3, 5 right there. So remember the 3 is in the x spot and the 5 is in the y spot. So in our equation, we're going to go ahead and put the 5 in for y and the 3 in for x. Then we're going to go ahead and solve for b. So now we're going to go ahead and multiply -1/2 times 3, and we get 5 is equal to -3/2 plus b. Then we want to get b by itself, so we're going to add 3/2 to both sides, because the opposite of adding -3/2 is subtracting -3/2. And remember, two negatives make a positive, so it's the same as adding 3/2. So then, remember that when we're adding fractions, we have to have the same denominator. So in order to make the 5 have the same denominator, we need to put it over 2. So how many halves are in 5? Wholes. So if you think about it that way, we need to multiply 2 times 5 is 10. So we get 10 halves is equal to 5. So that's where the 10 halves came from. In other words, we're multiplying the top and the bottom by 2. So 5 times 2 is 10. 1 times 2 is 2. And that's where the 10 halves came from. If you need more help on that, go ahead and message me. But we've got 10 halves plus 3 halves. And then remember, when we're adding fractions, we add the numerators. So 10 plus 3 is 13. So we get 13 halves is equal to b. Then we're going to go up to our top equation there and just substitute in what we know b is now. So we're going to make that into 13 halves. Then, to finish out our equation, we need to change back the 5 and the 3 into our y and our x. And that's our equation. We're done. So now we're back in the form y equals mx plus b, where we know our m and we know our b. Okay, then we're going to go to the next problem. And I didn't do problem number 3 because it's very similar to problem number 2. This is your exact problem. I just wanted to kind of give you a hint on it. If you do have additional questions, feel free to message me. The first 3 terms of an arithmetic sequence are as follows. So we've got -7, -12, and -17. And then we want to find the next 2 terms of the sequence. So note, to go from -7 to -12, we're subtracting 5. Then to go from -12 to -17, we're subtracting 5. So to find the next 2 terms, we're just going to subtract 5. Okay, lesson number 4. So the first one is all about using a substitution to solve a system of equation. So I'm going to give an example problem here and give you steps. Please make sure you're writing down the steps, and if I were you, I would organize my notes so I've got the steps on one side and then boxes to show my work, just like I've done on the computer screen. Solve an equation for one variable is step number 1. Note the second equation is already solved for y. Then we want to do our substitution. So we're going to take our other equation, which was our x plus y is equal to 5, and instead of our y, we're going to write what y equals. So note that second equation tells us that y equals 3x or 3 plus x. So we go ahead and write x plus 3 plus x is equal to 5. Then we want to solve our equation. So we're going to go ahead and combine like terms. So x plus x is 2x plus 3. is equal to 5. Then we subtract 3 from both sides, and we get 2x is equal to 2. Then we want to get x by itself, so we need to divide both sides by 2, and we get x is equal to 1. Then we want to plug back in to find the other variable. So I'm going to go ahead and plug it back in. I've got x plus y is equal to 5, so I've got 1 plus y is equal to 5. Subtract 1 from both sides, and I get y is equal to 4. Then we're going to go ahead and check our solution so we know that we're right. And we've got 1 plus 4 is equal to 5. And that's correct. And then we have 3 plus 1, which is equal to 4. And that's also correct. So we did it right. If something doesn't check out down here and you get to step 5 and your solution is not correct, go back to step 1 and rework. Okay, the next one is also a systems of equations. So Nick's school is selling tickets to a concert. On the first day, the school sold 3 senior citizen tickets and 1 child ticket for a total of $34. On the second day, the school sold 3 senior citizen tickets and 2 child tickets for a total of $38. Find the price of each ticket. So I went ahead and picked variables. I put S for senior citizen tickets and C for child tickets. So that first equation looks like this. 3 senior citizen tickets plus 1 senior child ticket is equal to $34. Then the next equation, 3 senior citizen tickets plus 2 children's tickets is equal to $38. Then we're going to use our steps again. So step 1, solve the equation for one variable. So this one's a little more complicated because we aren't given one variable. So we have to solve. So note that 1c is just c, because 1 times c is just c. 1 times anything is itself. So we get 3s plus c is equal to 34. So we want to get c by itself, so we need to subtract. Oops, my animations are showing up out of order here. Give me just a second. Okay, sorry, I got that animation out of order, but I want to go ahead and go through it anyway. So we've got 3s plus c. If we subtract 3s from both sides, we get c is equal to 34 minus 3s, or negative 3s plus 34. And sorry, once again, that'll show up a little bit later in the order. But there it is right there when I do the substitution. So I take the other equation, which was 3s plus 2c is equal to 38, and I have 3s plus 2 minus 3s plus 34 is equal to 38. So once again, I'm just substituting what c equals. Then I'm going to go ahead and solve the equation, and I need to use the distributive property. Once again, that's the Angry Bird property. So you're going to take 2 times negative 3, which is negative 6s, and then 2 times 34, which is positive 68. And you can see that there in that equation. Then we're going to go ahead and combine like terms. Once again, the ones that have s's are like terms, and we can add. So 3s minus 6s is negative 3s plus 68, which is equal to 38. Then we want to go ahead and subtract 68 from both sides, and we get negative 3s is equal to negative 30. Divide both sides by negative 3, and we get s is equal to 10. So our senior citizens tickets are equal to $10. So now we can plug back in and find out how much our child's tickets are. So we take child's, so I just took the equation from step 1 and plugged my s back into it because I had already solved for a c, or our child's tickets. So I took negative 3 times 10 plus 34 is equal to 4. So c equals 4. Because once again, negative 30 plus 34 is equal to 4. Then we want to go ahead and check our solution. So let's plug it back into both equations and make sure it works. And once again, if yours doesn't work, go back up to the first step and look at it there. So senior citizen tickets are $10 and child tickets are $4. And then finally, the last question in your project, you've got this graph and you're looking at 18. So I just went ahead and gave you a hint there. So we want to go up from our monthly water usage of 18 and then look at the Y values for the business plan and the residential plan, and you want to find the gap. Thank you for watching and good luck on your project.